morning. Myself Dr. Jyothi, working as an Assistant Professor of Physics, Department of Freshman and BSH in B.V. Raju Institute of Technology, Narsapur. Our course name is Applied Physics. Today's topic name is Effective Mass of an Electron. Coming to the definition. So what is effective mass of an electron? So effective mass of an electron is the mass of an electron. Effective mass of an electron is the mass of an electron when it is accelerated in a periodic potential. And it is denoted by m star. So what is the definition for the effective mass of an electron? Effective mass of an electron is the mass of an electron when it is accelerated in a periodic potential. So, and it is denoted by m star. We know very well when we representing the mass of an electron is m. And effective mass of an electron is m star. Okay, mass of an electron is m and effective mass of an electron is represented by m star. So, coming to the explanation about the effective mass of an electron. For calculating or for deriving the expression for the effective mass of an electron, so let us go for some explanation about the effective mass of an electron. So when an electron of mass, we know that m is equals to 9.11 into 10 to the power of 9.11 into 10 to the power of minus 31 kg. This is the mass of an electron. When an electron of mass is placed in a potential periodic and if it is accelerated with the help of electric or magnetic field, then the mass of the electron will not be a constant. Rather, it varies with respect to the field applied. So, means here mass when we are applying the external field, when we are applying the external electric field or magnetic field, the electron in a periodic potential, the mass of the electron will be changes. Means the electron mass will not be a constant. Means here the mass of the electron will be changes. The change of the mass of electron is called effective mass of an electron, which is represented by m star. So how to derive the expression for the effective mass of an electron? To study the effect of electric field on the motion of an electron in one-dimensional periodic potential, let us consider a Brillouin zone which contains only one electron of charge E in the state K, placed in a external field E. Okay, to study the motion of an electron, we are applying some electric field or magnetic field. So let us consider a electron in a one-dimensional periodic potential. So let us consider the charge is E and in the state which is available in the state is K. So we are that mass of electron. What happens? What is the mass of electron before applying the applied field and after applying the applied field? So let us calculate the expression for the effective mass of an electron. So due to the field applied, here we are applying some field. So the electron gains some velocity. So when we are applying the field to the electron, it gains some velocity, that is group velocity. Which is represented by Vg. Vg is called group velocity. Therefore, the acceleration changes. Therefore, the acceleration changes means the acceleration which is related to the velocity. We know the definition, the basic definition for the acceleration is the change in velocity is called acceleration. Then here we are applying the applied field. The electron gains some velocity, that is a group velocity. So it gains some velocity. So then velocity gains, then acceleration will also changes. So that is why, because we know the very well about the definition of the acceleration, that is rate of change of velocity. So it gains some velocity, the changes in the acceleration. So from the group velocity we can represent it by Vg is equals to d omega by dx. D omega by dx. Here k is the wave vector. Here k is the wave vector and omega is the angular velocity. Angular velocity, and we know that omega is equals to 2 pi by nu. 2 pi nu. Omega is equals to 2 pi nu. So from the equation, so 2 pi nu, we know the equation nu is equals to E by h. From the equation equals to h nu, nu is equals to E by h. So we have to substitute in this in the place of nu, we are substituting E by h. So this is the equation number 2. Substituting equation number 2 in the equation 1, we get the group velocity Vg is equals to 2 pi by h into dE by dk. dE by dk. So from the group velocity Vg equals to 1 by h cross dE by dk. dE by dk. So we know the value for the 2 pi by h equals to h cross. H cross equals to, or h cross equals to 2 pi by h, or h equals to 2 pi by h cross. So that is from the equation 3. When we are substituting equation 2, in the equation 1 we will get the group velocity, and also from the value of h cross we are substituting 2 pi by h. In the place of 2 pi by h we are substituting h cross. So final group velocity equation is Vg is equals to 1 by h cross into dE by dk. If the field E is applied to the electron for a time, here we are applying the field to the electron a time, say it is dt. It is dt seconds, then change in field or work done is equals to force into distance. Here we are applying the applied field to the electron with the time dt seconds. Then the change in field is equals to change in field or work done equals to force into distance. Here the change in field is equals to force F, for distance means velocity into time. Distance is equals to velocity into time. Velocity into time. So how much force we are applying here? When here we are applying the applied field, it has some charge of electron. This is this much force we are applying. So F is equals to E into E. E is equals to force and velocity into time. Velocity, Vg group velocity, time, force, then velocity, that is Vg, dt seconds, that is time. So work done equals to force into velocity into time. So then force into velocity into time, this is the work done. Substituting equation 3 in equation 4. So dE is equals to, what is equation number 3 here? What is equation number 3 here? So dE is equals to 1 by h cross dE by dk. 1 by h cross dE by dk. dE by dk. So then that is equals to equation number 3. What is equation number 3? Vg is equals to. Then Vg is equals to. So according to dE equals to what happens? Vg h cross by Vg h cross dE by dk. So dE by dk equals to Vg. What is Vg here? D equals to, in the place of dE we are substituting this value. We will get the dE is equals to E by h cross into dE by dk into dt. So here dk by dt is equals to E by h cross. dk by dt is equals to E by h cross. So we know the acceleration definition. This acceleration. What is acceleration? What is acceleration here? Group change velocity by time. Rate of change of velocity. So the rate of change of velocity means d group velocity here. So dvg by dt is acceleration. So from that, substituting vg equation, vg value from the equation 3, we get a is equals to d by dt of 1 by h cross dE by dk. So here for this equation we are multiplied and divided by with dk. So then d square, dk square, and the numerator also dk we have to write because of we are multiplied and divided with dk. So by dt. So what is acceleration? So acceleration means a is equals to 1 by h cross d square E by dk square into the dk by dt in the place. dk by dt, we know the value E is equals to h cross. So this in the place of dk by dt we are substituting E by h cross. So acceleration 1 by h cross square d square E by dk square E by h cross, or E is equals to, with respect to the E we have to write E is equals to 1 by h cross by d square E by dk square into d square E by dk square into A. So this equation 7 we have to compare with the Newton's force equation. So that is F is equals to ma. So here the effective mass of electron. So that's why we are writing m star A. We are applying some forces E is equals to E. F is equals to E into E. So in the earlier equation is h cross by E equals to E is equals to h cross by d square E by dk square, d square E by dk square into A. We have to compare with the Newton's force law, that is m star A. Just you have to observe this equation, just in the place of E is equals to m star A. In the place of m star we have a one value, that is m star is equals to h cross by d square E by dk square. This is we know that m star is the effective mass of an electron. So equation 9 represents the effective mass of an electron in a periodic potential, which depends on the d square E by dk square. Now let us talk about the d square E by dk square, how it is changes. That purely depends on the term, the parameter is d square E by dk square. So let us talk about this, some special cases. So because of this effective mass of an electron which depends on the d square E by dk square. So in the first case, if the d square E by dk square is a positive value, so then effective mass also positive value. So because of m star is equals to h cross by d square E by dk square. If it is positive value, that m star also positive value. Then if it is negative, d square E by dk square is a negative, then effective mass is also negative. If it is negative value, then effective mass of an electron is also negative value. Then d square E by dk square is 0, is equals to 0. Then effective mass of an electron means here something by 0. We know that is infinity value. These are the special cases. Why we are discussing on these special cases means that effective mass of an electron which depends on the d square E by dk square. This is the effective mass of an electron. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.